All right, and so we are moving on to our next unit here in geometry, and this is our first lesson in Unit 2, and this is going to be writing equations of lines. So you can see that standard form says that I can write equations of lines given different information. So this is going to apply in lots of different ways. So we're going to look at lines graphed. We're going to look at lines given in tables. We're going to look at just given a couple points. We're eventually going to get to writing parallel and perpendicular lines. That also means that you need to be able to write lines in different forms. So horizontal, vertical, slope-intercept form, point slope form, all those types of things. So in the short video before this one, all right, you went through all the different vocabulary associated with this lesson. All right, so I'm not going to go into that because that's in, all right, the prior video. And once again, you can see our four main, all right, standards here, right? I can find slope between 2 points both graphically and numerically. I can write equations of horizontal and vertical lines graphically and numerically, point slope form and slope intercept form graphically and numerically. And that's what I'm going to do with you now. I'm going to go through, all right, a handful of examples, all right, and to model all of these different situations for you. So this is on page 61 if I haven't mentioned already. So let's flip, all right, to page 62. Now I'm not going to spend a lot of time on the notes part here because obviously you can read through that. All right, you can go over, all right, and use that as a reference if you need a little bit more. So I'm going to just go through and jump into examples. So now let's flip to page 63, and let's look at problem 1. I can find slope graphically. And remember that we think of slope graphically as just rise over run, okay? And so we want to just go from point to point, all right? And typically you want to take the two closest points, and that'll give you typically a slope in lowest terms, but if not, just always reduce that slope using what you know about reducing fractions. So notice, if I go from this point here to this point here, all right, notice that I have to go down 1, 2, 3, and I have to go to the right 2. All right, so my slope then would be negative 3 over 2. All right, so I know my slope is negative if my line is going downhill from left to right. I should know my slope is positive if it's going uphill from left to right. And so that's just a review of how we find slope graphically. Like I said, I'm only going to do like spot examples here. I'm not going to go through a whole bunch of these. So since this is mostly review for you, all right, so that's the only one I'm going to do on page 63. All right, so let's go ahead and flip the page. Now, once again, that was graphically, right? But we also want to be able to do it numerically. What numerically means is either we have a table of values or we're just given a couple of points, all right? And so when we look at finding slope, it's really the same idea, all right? So now if we flip to page 65 and let's look at number 5 here. So now we have this table, all right? Now, typically we can think of slope in different ways. So when we're thinking about it graphically, we think about it as rise over run. But then what that also is really telling us is really the change in y to the change in x. And what makes it linear is that that gives us the same ratio every time. Okay, so it might look different, but if we reduce it, it's the same. So I might get 4 over 1, and I might get 8 over 2, I might get 12 over 3, right? But all of those reduce to 4 to 1. So it's really saying we have the same type of change. And that's what we have to see when we're given a table here. So notice when we look at our table, all right, we might have different changes, but it's the ratio in the end that we want to be the same. So when I look at number 5 here, notice when I go from 17 to 24, I go up 7. And then when I go from negative 2 to 1, I go up 3. So my first rate of change, all right, my first rate of change is 7 to 3. So remember, change in y to change in x. Well, notice what happens on my next change here. So when I go from 24 to 38, this time, I go up 14. So it looks like it's going to be something different. But if I look on the other side, look how my x's change. I go from 1 to 7, so it goes up 6. So my next rate of change is 14 to 6. And it looks different. It looks different. But now, once again, if we reduce that, this is why we always want to look at slope in lowest terms, is to see if we are really talking about the same thing. And notice 14 and 6 are both divisible by 2. So if I reduce this, this brings it to 7 over 3, which says, okay, it's the same thing. And then as I progress through my table, I go up 7 again, and I go up 3, so I get another 7 over 3. All right, here I go up 7, I go up 3, I get another 7 over 3. And then here, once again, I go up 14, and then I go up 6. All right, and I get another 14 over 6, which you said is 7 over 3. And because all of those rates of change are the same, that means we have a constant rate of change, which means we have a linear function. And that'll be important because we have to know it's linear before we can write the type of equation. All right, so my slope for this would be 7 to 3. And that is all we have to do. All right, but it's very important that you go through the entire table and make sure that it is constant. Make sure you get that same ratio each and every time. All right, now let's jump to problem 8. Okay, let's jump to problem 8. So notice we're just given 2 points. All right, well, if we're given 2 points, what we want to do is make it this problem again. We just want to make a quick XY table, all right, and just throw those points into that table. So we have a 4, 7, and we have negative 2, 6, like this. And we want to do this exact same thing that we just did. We want to find the change in y and the change in x. And so notice when I go from 7 to 6, I go down 1. And when I go from 4 to negative 2, I go down 6. And so my rate of change would be negative 1 to negative 6. Now, once again, we want to reduce that. We want to simplify that. And a negative divided by negative is a positive. So my rate of change is 1 over 6. Now, notice we don't have any other rate of changes to compare this to. So we assume it's linear when we have 2 points. We're going to assume that that rate of change would hold true. All right, so there's a bit of an assumption that we can only write an equation of a line through 2 points. All right, so we're going to assume that that slope is, all right, going to remain 1 over 6, all right, as we move forward. So if we have just 2 points, you just make it a table problem, and then it's the same idea. All right, so there's how we find slope graphically, and that's how we find slope numerically. And we had to go through both of those because the next step, all right, if we flip to page 66, all right, is that we now start writing equations of lines. All right, and we're going to have to be able to find slope for most of those types of problems. Now, for the first 2 types of lines, vertical lines and horizontal lines, we don't really have to find slope. We can just look at them and understand, all right, that this is the equation of a vertical line, all right, and y equals b is the equation of a horizontal line, and we can just write the equations. We don't have to find slope. All right, but on everything else, we do. So now let's look at page 67. All right, and I went ahead and outlined these in green just to make it a little bit easier for you to see. All right, so notice this is how easy it should be. Number 11 is a vertical line. All vertical lines have a equation of x equals a. And notice this goes through x equals negative 3. So the equation of this line is just x equals negative 3. And that's all you have to do to write the equation of a vertical line. Now, if it asks what the slope is, the slope of a vertical line is what we say is undefined. And that is because there is no run. So we have a rise, okay, so we always have a rise, but there's no run, right? We're not going left or right, and we can't divide by 0, which is why we say that slope is undefined. All right, now if we look at number 12, notice we have a horizontal line this time. And it goes through y equals 8, and that is simply the equation, y equals 8. Now, the slope of a horizontal line is 0, because if we look at that, in a horizontal line, there is no rise, but there's run. And it's okay to have 0 in the numerator, because 0 divided by any number other than 0 is still just 0. So the slope of a horizontal line is 0. All right, so that wraps up writing equations of horizontal and vertical line. All right, so flip the page. Sound like one of those old recorders. All right, so what we're going to do now, all right, is we're going to go through writing equations of lines in point slope form. All right, and once again, you can see that there's some very specific examples here on page 68 for you to kind of refresh everything if you need it. I'm going to jump in and go through an example with you here. Now, once again, the first step is that to write the equation of a line, all right, we need to know the slope. All right, we need to know the slope. And we just did this example a few minutes ago, and we found that the slope of this line was negative 3 over 2. Now, when we're writing in point slope form, we have to have slope. And then we call this point slope form because those are the two things we have to have. We have to have the slope and the point. Now, what's nice about writing the equation of a line is you can pick any point you want on that line. All right, so you can pick this point, pick this point. We could go down another 1, 2, 3, and over 2, and there's another point. All right, so you can pick any of those points on the line. All right, So there's several possible right answers when you write the equation of a line, depending on what point you pick. All right, so I'm just going to pick this point right here. All right, -5, 1, just like that. And then we just take that information and we plug it in. So y equals -3/2, and then x minus -1. Now notice if I'm going to put a negative in, x minus -5 makes that a +5. All right, and then a +1. And there's my equation. And as long as it says just point slope form, you can leave it like that. There's nothing else that you need to do. All right, so that is point slope form, all right, graphically. Now, all right, once again, if you look at page 70, all right, once again, all right, very detailed instructions for you, all right, to refer back to. I'm going to go ahead and jump into an example here, all right, and so, all right, let's look at example, all right, 19. Now, once again, it doesn't matter what form it's in, all right, whether it's graphical, whether it's numerical, we have to get this and extract the same information no matter the context. So if we're writing in point slope form, we have to have the slope and we have to have the point like we did before. And notice that just means how we find the slope might change. All right, and we know from our prior example, all right, that the slope of this, all right, was 7/3. Now, once again, now it's a little different. So we have 1, 2, 3, 4, 5, 6 different points you can pick. So you can pick any point in this table. All right, and it does not matter. All right, so that means there's 6, all right, possible correct answers here because 6 points could be picked. I'm going to pick the last point here, which is 1966, or 19,66. And then once again, we just take that point, we take that slope, and we plug it in. So y equals 7/3, and then we have x minus 19, all right, and then plus 66. And that is all you have to do. All right, so there's an example of how to write an equation in point slope form, both graphically and numerically. All right, so let's move on to the last topic, which is slope-intercept form. All right, now what I'm going to talk about with this is that there's really two ways to get to slope-intercept form. One is that you know the slope and the y-intercept, right? We can find the y-intercept either on the graph or in the table, and we can use that point and plug it in. The second way requires a little bit more algebra. All right, it's where we can't see the y-intercept in our graph or in our table, and we have to do a little bit of algebra to simplify into slope-intercept form. And I'll show you how to do that as we progress. Now, once again, on page 72 here, you've got the full set of notes if you need to go back and refer to them. All right, so let's look at, okay, problem 25 here. All right, so once again, when we think about this, this is slope-intercept form. All right, so y equals mx plus b. So slope-intercept. So I have to know my slope, which is m, and then b, remember, b is our y-intercept, so that's 0b. So that we want to find where it crosses the y-axis. All right, so let's find slope. All right, so now notice if I go from point to point here, I go up 1, 2, 3, and I go over 1. And I can see that that continues all the way up our line here. So 3/1, 3/1, 3/1. So I can see that my slope is 3/1. Now notice I can clearly see here, right, where it crosses the y-axis. I can see that it crosses at 0, 5. So I can clearly identify my slope. I can clearly identify my y-intercept. So now I can just plug it into my equation. So y equals, all right, 3x plus 5. And I am finished. There's no other work to do. Done. All right. So if I see the y-intercept and I can count my slope, I can go right to my equation. Now, let's look at 28, though. Now, this is where it gets a little bit, all right, more, and I won't say more difficult. I'll just say it lengthens the process, all right, to get to that equation. Because notice I can find my slope just like we did before. All right, so 1, 2, 3, 4. So up 4, whoops, up 4 to the right one. And then up 1, 2, 3, 4 to the right one. So I can see that I get that slope of 4/1. All right, so my slope is 4/1. Now here's the issue. All right, I want to write this in slope-intercept form. But notice I don't have a big enough picture here. It looks like eventually it will cross the y-axis somewhere, all right, very negative down here. All right, but I can't see it. And if that happens, we want to just start by writing the equation in point-slope form. All right, so I'm just going to pick a point. All right, I'm going to pick this point right here, 5, negative 4. And so if you don't know your y-intercept, we just go back to what we can always use, which is point-slope form. So now if I write this in point-slope form, this would be y equals 4, and then x minus 5 minus 4, like this. And now what we want to do is just 2 steps of algebra to simplify this equation. And notice when we go back to slope-intercept form here, there are no parentheses. So what we want to do is distribute first and go ahead and get rid of the parentheses in this problem. So 4 times x is 4x. And then 4 times negative 5, that's negative 20, and I can bring down that negative 4 that's on the outside. And now notice now I have 2 like terms hanging out here. I've got negative 20 and negative 4. So I can combine those. And notice, once I distribute and combine like terms, what form am I in? You guessed it, we're in slope-intercept form right here. All right, so remember that you can always get to slope-intercept form from point-slope form. It just requires 2 steps of work. All right, so distribute, combine like terms, and that's all you have to do. All right, so let's move on. All right, very long lesson here. All right, a couple more examples. Now, once again, same kind of process, right, if we want to do slope-intercept form numerically, right? Okay, so I'm just going to, all right, look at some examples here. All right, and so once again, if I go back, all right, to this example here, all right, now I want to make sure we're good because when we're looking for a y-intercept, right, so what we know for a y-intercept is it's always 0b. It's always 0b. So when I have a table, I want to look for an x-coordinate of 0. So once again, notice, I don't see an x-coordinate of 0, so I don't have 0b. All right, versus if I look over here on 30, when I look down here, I see x equals 0, so right here would be my y-intercept. So when you're looking at a table, all right, we have to just, once again, kind of get in our mind, what does that mean to be a y-intercept? That means x has to be 0. So if I see x equals 0, I know my y-intercept. If I don't see x equals 0, all right, that means we have to go through that same process that we just did. All right, so once again, when I look at this, we know that this is 7 over 3. All right, and then I'm just going to pick 738 as my point here. All right, and then once again, right, I'm going to just go through my process. So I'm going to squeeze it in here, 7 over 3, and then x minus 7 plus 38. Now notice sometimes what this means is we might get fractions, we might get decimals. It happens. Don't freak out about it. Because notice when I distribute here, I'm going to get y equals 7 over 3x minus, and I'm just going to keep this in fraction form, 49 thirds. All right, and then plus 38. Now, if you do this with a calculator, you're going to get decimals here. But see if you can keep it in, all right, fraction form because you're going to have an exact answer. So then 7 over 3x, and then once again, notice we still get like terms here. All right, so now when I combine those, all right, so 38 times 3, that's 114. So if I think about converting to thirds, this would be 114 thirds like that. And now I can just combine. All right, I can do negative 49 plus 114, and I get plus 65 thirds. All right, so there was our point-slope form, and then we get to our slope-intercept form right here. All right, so you have a lot of problems to work through here. All right, so I'm going to turn off the video and let you guys get to it. Be sure to check your work on the answer key, and I'll see you for the next lesson.